aromaticity of the pyrrole molecule. The molecular formula of pyrrole is C6H5N. The 4 carbon atoms of nitrogen are sp2 hybridized. The 2 sp2 hybridized carbon atom form sigma bond. So the 4 carbon atoms, that is this 1, 2, 3, 4, they are sp2 hybridized. 2 sp2 hybridized carbon atoms form sigma bonds with 2 carbon atoms and 1 hydrogen atom. So these 2 sp2 hybridized carbon atoms form 2 sigma bonds, one with the carbon atom, neighboring carbon atom, and one with the hydrogen atom. The other 2 sp2 carbon atoms form sigma bonds with the neighboring carbon atoms and 1 hydrogen and nitrogen. So this is forming only with the hydrogen atom, whereas this molecule forms with these 2 carbon atoms form sigma bonds with the neighboring nitrogen atom and the hydrogen atom. Each carbon atom contains an unhybridized p orbital with 1 electron each. Pyrrole exhibits resonance, which results in it producing the negative charge. So because pyrrole is exhibiting resonance, therefore it has a negative charge inside it. So pyrrole molecule will go like this when it is in the resonance form. So this carbon atom, this carbon atom, this carbon atom, this carbon atom, so for this carbon they were saying that this carbon will form sigma with this, sigma with this neighboring, so neighboring 2 carbon atoms and with a hydrogen atom. But for this carbon atom it will form sigma over here, sigma over here, and with the hydrogen. So this, for this carbon, sigma over here, sigma over here. So it will form 1 with the nitrogen, 1 with the neighboring carbon, and 1 with the hydrogen molecule. So it will form like this. So if I split this, what I get? I understand that from this carbon atom will form 1 sigma with the neighboring carbon, 1 sigma with this neighboring carbon, this neighboring carbon, this neighboring carbon. So it forms sigma bonds with the 2 carbon atoms and with the hydrogen, 1 hydrogen, 1 sigma with 1 hydrogen. But if I talk about this carbon atom, it will form 1 sigma with the neighboring carbon atom, 1 sigma with the nitrogen, and 1 sigma with the hydrogen. So sigma bond with the neighboring carbon atom, 1 hydrogen and nitrogen. So 2 of them will follow this order. 2 will follow this, 1 sigma with 1 carbon, 1 sigma with the other carbon, which is 2 neighboring carbons, and 1 with the sigma with the hydrogen, and 2 carbon atoms will follow this, 1 sigma with carbon, 1 sigma with nitrogen, and 1 sigma with hydrogen. Each carbon atom contains an unhybridized p orbital with 1 electron each. So because of resonance, nitrogen will carry a positive charge in case of pyrrole. Normally, nitrogen carries a negative charge, but only for pyrrole, it will carry a positive charge because of high resonance energy. it will produce negative charges and positive charges on nitrogen. So nitrogen will carry a positive charge also. In case of pyrrole, the NC2 and NC5 bonds. So NC2 and NC5 means this is C. Wait. This is 1. This is 2. Okay, I will draw it again. So let's see, this is like this, this is like this, this is like this, this is N, there is H. So if I start from here, this is 1, this is 2, this is 3, this is 4, this is 5. So NC2, that means N with carbon atom C2, N with carbon atom C2. So this is C2, this is N. So N with carbon atom C2 has a bond angle. This bond length will be 1.38 stronger. This bond length will be 1.38. With carbon atom C5 and N, the bond length will be again 1.38 strong. C2 with C3, so this is carbon C3. So I have done a numbering. C2 with C3 will be, bond length will be 1.37. Then C2 with C3 and C4 with C5. This C4 with C5 will have a bond length of 1.37 and C4 C3 will have a bond length of 1.43 strong. Resonance energy is given 24 kilocalorie. So you should learn like this according to the diagram. C2 with nitrogen 1.38, C5 with nitrogen again 1.38 is the bond length. C2, C3, C4, C5. C2, C3, C4, C5 is 1.37 and C3, C4 is 1.43. So, how does it enter into the resonance? So, first, this is the pyrrole structure NH, and the structure can be equivalently written like this. NH, one bond, N having 2 lone pair of electrons. This goes into the resonance and this will go into the cycle. So this will come over here. So we say this like this, this is N, this is H. This bond got shifted over here, this bond got shifted over here, and the positive sign shifted over here on this nitrogen because the lone pair got over here. So we show that negative charge is over here along with 2 lone pair of electrons. So why we show here positive sign? Because nitrogen loses the lone pair. Nitrogen loses lone pair. So we all know that when an atom loses electron, it becomes positive charge. When an atom gains electron, it becomes negative charge. So this is loses and this is gains. So since nitrogen is losing, nitrogen will have a positive charge, negative charge will shift. Again, there will be a resonance structure. This will go over here, this will go over here, positive charge will go over here. So this will look like this. NH So the cycle will go on continuing like this. The bonds will go on getting shifted. Therefore, we say that this is the actual resonance structure. Okay. With negative charge, we show like this. Inside the ring, we show a negative charge because the negative charge is going on moving. So first the negative charge was here, then it went over here, then it went over here. So because the negative charge is going on flowing, so we show it like this. For pyrrole, we say that this is the ring and there is a negative charge inside the ring which is flowing. Nitrogen is positive and you have a hydrogen possible. So the first question arises in our minds is, after learning this resonance hybrid structures of the pyrrole, is pyrrole aromatic compound? Is the pyrrole an aromatic compound? So if you take this, you see 1 electron, 2 electron, 3 electron, 4 electron. So you say that there are only 4 electrons, but we forget these 2 electrons which are present as lone pair. If we consider these 2 electrons, we have 6 electrons in total, and we know that if it has 6 pi electrons, it will follow the Huckel's rule of 4n plus 2 pi electrons. The molecule is cyclic because it is undergoing resonance, and we show it as a ring with a negative charge. Molecule is planar. It has a high resonance energy which is 22 kilocal per mole. The resonance energy for pyrrole is 22 kilocal per mole. For benzene, it was 36 kilocal per mole.